Good. So in our yesterday's class, we understood what is an interface and what is abstract class and how they are different from each other. And we understood how many different types of inheritance exist and what is multiple inheritance and how it is important. And after that, we started with something called as overriding, and we understood how overriding is done and the difference between your abstract and virtual keywords. And after that we moved on to our next concept called as overloading, and we understood what is overloading. And after that we understood what is compile time polymorphism and what is runtime polymorphism, how are they different from each other. And with that we have completed inheritance, polymorphism and abstraction. Fine. Finally, our last topic for the object-oriented programming class is something called as access modifiers. Fine. Before understanding what is access modifiers, let's try to understand what is encapsulation first. Fine. What is encapsulation? Do you have any idea? Yes or no? Good. Encapsulation is a process or a property of your object-oriented programming through which you can restrict the scope of access related to a particular type or a member. Fine. So let's try to understand what is encapsulation with an example. Fine. Think that you have a somebody knocked your door, and you opened the door and you found the pizza boy. Fine. You have ordered a pizza and he brought it. So what will you do? Will you ask him to come and sit down in your living room and offer him some tea and coffee and talk some personal details with him, or you will just take the pizza from him and send him away? You will not do that, right? So the scope of access to your house for this pizza boy is restricted to the entrance only, right? And again, think that again somebody else knocked the door and you found that it's a neighbor. So you will ask your neighbor to come to the living room, right? And you will ask him to sit there and you'll talk to him. Fine. Will you allow him into your bedrooms, kitchen, personal spaces in your home? No, right? So the scope of access to your home for your neighbor is still the living room, right? And again, if somebody else knocked your door and you open to see some of your family members, will you restrict the access to him to only certain areas in your home? You'll not do that, right? You'll give him access to the entire home, correct? Yes or no? Good. So similar to this concept, you have a process in your object-oriented programming through which you can restrict the access to your code based on certain criteria. Fine. You can define the scope of access related to your code for any other code which is trying to refer to your code. Making sense? How will you do that? You can, so this process is called as encapsulation. And how will you implement encapsulation in your object-oriented programming? You will implement your encapsulation in your object-oriented programming using a concept called as access modifiers. Fine. What is access modifier? Access modifier is a keyword which will define the access related to a particular type or a member. Scope of access related to a particular type or a member. Fine. Have you ever come across a access modifier anytime? No. Did you see the term called as public, protected, internal when you are defining a class or a member inside the class? We have used it, right? So these are access modifiers basically. So what is how many different types of access modifiers exist in your C#? Basically there are 5 types of access modifiers in your C#. Fine. The first and foremost or the basic one is your public access modifier, which says that you are not restricting the access. any code from any place can access your code, access the defined type or member. Making sense? Good. The second one is called as protected. So think of a scenario where you have class A and you have derived a new class called as class B from your class A. Fine? Understood? So there is a third class called as class C, which is nowhere related to A and B. A and B are related through inheritance, but C is not related to them. Now, in this case, when you are defining something, some member as protected in your class A, then that would be accessible in from accessible to any member, any other member which is defined in your class A, or any member of class B. However, it would not be accessible to class C, which means that scope of your member is restricted to the containing class and its derived classes when you have declared it as protected. Fine? Making sense? Good. Third one is called as internal. Before understanding what is internal, let's try to understand something called as assembly. Do you know what is a assembly? Assembly is a unit of deployment. What is that? Unit of deployment. For example, think that you have written some code. You have written some code and you want to share it with your client. How will you share it? Will you directly give the code to him and ask him to execute by himself? You'll not do that, right? You'll compile your code and that compilation will generate some files like your exe files. How will you install Skype or any other software in your local machine? It will give you a exe, right? So your code will be converted into exe and you will use that exe to share the code with your end clients. Similarly, there are some other types of assemblies also. Exe is assembly which contains compiled code and which is used for deployment in your end client. And apart from that, you have some other type of assembly called as your DLL. Fine. What does exe refers to? Exe refers to executable and DLL refers to dynamic linked library. Fine. There are two types of assemblies. Understood? Good. That being said, think of a scenario uh, where Vishwa has created a printer document. Fine. So printer application which is used for printing the documents. Fine. And Sneha and myself, we have created two document viewer. Sneha's document viewer is about viewing Adobe files and my document viewer is related to viewing Word documents. However, we have received a requirement which says both Sneha's and my code also should have a new functionality associated with them called as printing the documents. Fine. How will you do that? So we will not rewrite the code, but what we will do, we will get Vishwa's code as a DLL and we will add the DLL as a reference to our project and we'll start using the classes which he has defined inside his class, inside his code. Fine. Understood? That being said, when you are, should we include also? What does that mean? I did not get you. You will add it as a reference. You will add it as a reference to your project and you will start referring to the namespaces which are defined inside it using system, that is called as import namespace. Okay, so you will import the namespaces. Okay, that is a part of adding reference. Fine. Good. So that being said, you will add that as a reference and you'll start using the classes which are defined inside it. However, you'll not be able to see the code or you'll not able to understand what or how it is implementing, but you can just go ahead and implement it. Fine, by adding it as a reference. So now what? Fine. So now when you are trying to create a or access a member or a type which is defined in some other assembly which you have added as reference to your code. Fine. In that case, there is one other access modifier called as internal. Okay, think that Vishwa has some more specific code related to his project, and he don't want to share that code with anyone who is referring to his code, or who is accessing his code through a assembly. Fine. Then he will define that code using a access modifier called as internal. And if you define something as internal, then that would be scope of that would be restricted to that assembly only. If somebody else is trying to refer to that piece of code through a reference to this assembly, then he will not be able to do that. Making sense? Understood or not? No. What is the question, Vishwa? Please unmute yourself and start asking the question. Vishwa, are you there? That's what I said. Okay, if you mark it as internal, then that would be restricted to only the containing assembly. Okay, so you can't access it outside the containing assembly. Fine. So you have created some code, and you don't want some component present inside your assembly to be accessible to something else which is referring to your assembly, some other code which is referring to your assembly. Then you'll mark it as internal, which means that it is internal to that assembly and it can't be accessed from any code which is not defined in that assembly. Fine. Making sense? Good. So next you have some other type of access modifier called as private access modifier. Fine. So what does your private access modifier do? If you have defined something as private, then the scope of that is restricted to only containing class, which means it can't be accessed from a code which is present inside your derived classes, or it can't be accessed from anywhere else apart from the assembly where it is declared, sorry, class where it is declared. So if you have a class A and class B and class C, and class A and class B are related through inheritance, then anything which is defined inside your class A as private cannot be accessed from class B or class C also. Fine. Making sense? It is restricted to only the class in which it is defined. Understood or not? Good. Finally, you have a hybrid access modifier called as protected internal. So what does protected means? Protected means the scope of it is restricted to the containing class and the derived classes, and internal means the scope of it is restricted to the containing assembly only. Now, protected internal will take the advantage of both of them. Okay, it is combination of both of them. Making sense? Yes or no? Vishwa, you want me to repeat that? So let me explain it using a diagram. Let me explain it using a diagram. Think that I have a assembly called as assembly A. Right? This is my assembly A. And I have one more assembly called as assembly B. Fine. And inside this assembly, I have defined three classes. Class okay, and both these classes They are related through inheritance. Understood? And now there is one other class called as class B. Okay, so think that this is X, X, Y, Z, W. Fine. So now think that these are again related to each other, or that these are again related to each other using inheritance. Fine. Make sense? Good. So now if you have defined X as, okay, so if you have defined something inside your X as protected, fine, will it be accessible inside your W? Why no? If you have declared something as protected, it should be accessible inside the same class or containing class and all the derived classes also, right? Here W is derived class of X. Okay, it is in some other assembly, but still it is the derived class of X, right? So now anything which is defined as protected inside your X should be accessible inside your W also, right? Because protected makes the member accessible inside the containing class and its derived classes also, right? Vishwa, is it clear till this point? Good. Now if you have defined something as internal in your X, okay, will it be accessible to W? No, because it's restricted to only assembly A, right? Yes or no? However, it would be accessible from Y and Z. Fine? Good. Now if you have defined something in your X and you have marked it as protected internal, okay, then it would be accessible inside this assembly only and inside its derived classes only. Fine, which means if it is defined as protected internal, it would be accessible from Y if X and Y are related through inheritance, but it would be, let me draw something else called as, okay, I call it S. Okay, and this X is related through inheritance with X also, with S also. Fine, then it would be accessible to S, but it would not be accessible to W. Fine, because it takes the features of both both protected and internal. Got it? Making sense? Is it clear now? Good. So that's about here protected internal. So how many different types of access modifiers exist? First one is public, which means no restriction, and second one is protected, which means it is accessible in the containing class and its derived classes, and third one is internal, which means it is restricted to only containing assembly. Fourth one is private, which means it is restricted to only the containing type or class, and fifth one is protected internal, which takes the properties of both protected and internal. Is it clear? Vishwa, is everything clear? Any questions? Good. Fine. So now let's do a quick recap of what we have understood till now. First thing, we started with object-oriented programming, and we understood that before object-oriented programming, there used to be a concept called as procedure-oriented programming, where you used to write more number of lines of code for implementing less number or minor functionality or very small functionality. And due to that, there were few drawbacks associated with that feature, where your code will not be readable because you have to write more number of lines of code, or hundreds of lines of code if you are implementing a very minor functionality also, which makes it tough to understand. Second thing, maintainability is also a drawback there, because when you can't read the code quickly, you can't fix any changes or make any changes to your code when they are required easily, right? Understood? And third drawback associated with your procedure oriented programming was that it it doesn't have proper reusability concepts through which you can reuse the existing code which was written in it. So due to all these drawbacks, they have come up with a new model of development called as your object oriented programming, where all these drawbacks were overcome. And that being said, class and object are the two important concepts associated with your object-oriented programming, and class is a template using which individual objects can be created, and object is the real-time instance of your object. Sorry, object is the real-time instance of your class, and you will use the keyword called as class to create a class, and you will use the keyword called as new to create the create the object. Understood? Good. And we understood that there are two different types of members which can be defined inside your class. One is called as field, other one is called as method, and field is used for saving some value to your memory using your class's object, and the and it defines some particular property associated with your class or attribute associated with your class. And the second member is called as function or method, and your function or method is a series of statements which are executed sequentially under a single name, and the function or method may accept few parameters and it may return a value. Fine. And the name of your function along with the parameters being accepted and the return type is together called as your signature or definition of your function, and the code or the statements which are executed by your function are called as implementation of your function. Understood? Yes or no? Good. So after that, we started understanding the principles of your object oriented programming. We started with something called as inheritance, where inheritance is a property which is used to create a new class from an existing class, and the new class should be able to access few or all of the members which are defined inside your parent class. And you will define inheritance using a keyword called as colon, and anything which is defined to the right side of your colon is called as the base class or parent class, and anything which is defined to the left side of your colon is called as child class or your derived class. Fine. Good. There are multiple types of inheritance. First one is your single inheritance. Second one is called as your hierarchical inheritance. Third one is called as your multi-level inheritance. And fourth one is called as your hybrid inheritance. Fifth one is called as multiple inheritance. Multiple inheritance is a concept where your child class would be derived from more than one parent classes. And importance of it, what is 4 in C#? I did not get you. Why so? What happened to the fifth one? I did not get you, Vishwa. What happened to the fifth type of inheritance? Okay, I got you. So fifth type is not supported through classes, but still C# supports multiple inheritance. Fine. But you'll have to use interfaces. Awesome. Good. So that's about your inheritance. And coming to your, one second, man. So one second, somebody is calling. Just one. Fine. So the second concept is called as polymorphism, where we understood that polymorphism means that taking multiple forms, and your methods would be taking multiple forms here. And we understood that there are two types of polymorphism existing, and first one is called as, one second. Guys, just a second, just give me a second. Guys, I think we should drop the session for today. We are done with object-oriented programming because I got some other important call from office. So I thought of revising everything which we have discussed, but unfortunately, I'll have to pitch into some other call. Okay, so we are done with object-oriented programming today, and our next concept would be something called as .NET Framework Basics. Okay, Sunil, can you hear me? Are you there? Sunil, are you there?
Yeah,
Sunil,
Anil,
one
yes.
second. One second. I think I have muted myself. I'm sorry, I have turned off the speaker. Yeah, Sunil, can you hear me?
Anil Garu, yes.
Yeah, good. So why did you join?
No, actually, Ashish is calling you, I think, I guess.
I know. That's what I joined his call.
Okay.
Okay, fine. I'm
Okay, Anil.
dropping off, guys. Thank you. Bye.
Thank you, Anil Garu.
No problem.